Welcome to another episode of Tutorials with Ike. If you are new to this channel, please don't forget to like this video, subscribe, comment, and share with your friends so that they would also benefit from it. Now, today I'm going to be looking at differentiation under quantitative methods. And this is a very crucial topic because it comes in exams almost every year. You get it. So now, what is differentiation? Differentiation is a concept which was brought up by Isaac Newton and a German mathematician called Gottfried. Gottfried Leibniz. So these were the two people that brought up differentiation. Isaac Newton actually brought up the idea, but then Gottfried Leibniz brought up the dy dx function and all that to get it. So you are going to explain all that. Now, what's the whole concept behind differentiation? Now, differentiation tells you how things change with respect to something. You get it. So if, let's say, in a company, you want to know maybe how, let's say, profit is going to increase when maybe you add one additional worker and all that, you use differentiation for it. So differentiation just tells you the rate of change of something or a function. You get it. Now, we are going to look at some basic rules of differentiation. Before you solve any question under differentiation, you have to know these things. Now, the first thing is that if you have, let's say, something like this, negative 4x squared, negative 6x cubed, and negative 18 x exponent 4. If you have something like this, a number and an exponent as well as a variable, and you want to differentiate it, the first rule is that you multiply the exponents times the base. You get it? So 2 times negative 4 will give you negative 8, right? So negative 8x. Then you reduce the exponents by 1. So it becomes negative 8x exponent 1, but it's the same as negative 8x, you get it. So you do same for this. Assuming in exams you are given this to differentiate, negative 6x exponent 3. You multiply 3 times negative 6. What are you getting? You are getting negative 18. So negative 18x. Then you reduce the exponents by 1. So it's 3 minus 1, which is 2. You do same for this. If you are given this in the exams to differentiate, you multiply the negative 18 times the 4. So negative 18 times 4 will give you 72, right? Negative 72. So negative 72x. Then you reduce the exponents by 1. So negative 72x cubed. You get it. If you also have, let's say, something like 11x exponent 5, you want to differentiate something like this, you multiply the 11 times 5, so the base times the exponent. 11 times 5 will give you 55. Then bring the x, then you reduce the exponents by 1, so to be 4, because 5 minus 1 is 4. So this is the first rule you have to know. When there's an exponent, you multiply the exponent by the number there, then you bring the variable there, which is the x, then you reduce the exponents by 1. So this is the first rule you need to do. Now, the next thing you need to know is that if, let's say, you have a number without an exponent, so let's say something like negative you have something like negative 11x, or maybe negative 18x, or 25x, any of this. You realize that the first one there were exponents, but this one there are no exponents. So when there is no exponent and you are differentiating it, you just assume that you've not seen the exponent. You get it? So if, let's say, you're asked to differentiate negative 11x, the answer will be negative 11. That's all. So if you are differentiating negative 11x, just remove the variable attached to it. That's if there's no exponent. You get it? So negative 11x, if you are differentiating, you're just going to get negative 11. You do same for negative 18x. If you're asked to differentiate it, you just remove the x. So it becomes negative 18. You get it? And then for this one as well, if you're asked to differentiate it, you assume that there's no x, then it becomes 25. You get it? So when asked to differentiate something like this, a number and a variable attached to it, just remove the variable from it. That's all. Now, the last thing you need to know, that if you are given something like just a number to differentiate, so if it's something like 11 or 5 or even 6, it becomes 0. You get it? So if you are asked to differentiate 11, the answer will be 0. Similarly, if you're asked to differentiate 5, the answer will also be 0. If you're asked to differentiate 6, then the answer will also be 0. You get it? If you're asked to differentiate a constant, there's no variable attached to it, the answer is 0. So now these are the three things you need to know when it comes to differentiation. Now that we've understood this, we are going to take some practical examples when it comes to differentiation. And you remember that from the beginning, I told you that differentiation also tells you the rate of change of something. You get it? And remember that in accounts, when you have, let's say, total revenue, which is TR, and you want to know the rate of change of the total revenue, you use what you call the marginal revenue. So in economics, marginal revenue means that the additional revenue you are getting when someone joins. Let's say when there's an additional labor, you get it. So when one person joins, what's the additional revenue he's bringing? Also, if you have, let's say, total costs and you want to know the extra costs that is in the company, you use what you call the marginal cost. So marginal cost is the extra cost you are incurring per an additional unit. You get it? So now understanding this, if you have a total revenue function or you have a total revenue and you want to find the marginal revenue, which is the rate of change of the revenue, you can just differentiate the total revenue function, then get the marginal revenue function. You get it? Because anytime you differentiate something, it's just telling you the rate of change of it, how it changes with respect to something. Similarly, if you have the total cost function and you're asked to find the marginal costs, you differentiate the total cost function. That's how come you can find the marginal cost. So we are going to take some practical examples for you to understand everything I'm saying. So now let's take this question. So the question says that the demand function for a good is given as P is equal to 50 minus 2K. A. Write down expressions for the TR and MR functions. B. Calculate the level of output that maximizes total revenue. Alright. So we are given the demand function as, so the demand function is equal to, so the demand function is P is equal to 50 minus 2Q. So this is the demand function we've been given. And they are saying that you should find an expression for TR and MR. TR is total revenue, MR is marginal revenue. So they are saying you should find the total revenue. Now, from our knowledge in economics, you know that total revenue is the price times quantity. You get it? And the P here is for the price. So you've been given the price already. Anytime they give the demand function, you can find the price in it. You get it? So anywhere you see P, just know that is the price. So now that they've given us the price, and we know that total revenue, which we are supposed to find for, is price times quantity, we can just multiply our price times our quantity, which is Q. So to find the total revenue, into brackets TR, know that the total revenue is price times quantity. However, we've already been given price. So they said the P or the price is equal to 50 minus 2Q. So our total revenue is equal to 50 minus 2Q. This is our price. Now we've taken care of the price, then times the quantity, which is our Q. So times Q. So this is how we find the total revenue. Now we can just simplify it. So 50 times Q is giving us 50Q. Then minus 2Q times Q is giving us 2Q squared. So now this is our total revenue function. So always just put it to your head. Total revenue is price times quantity. So when they give you the function and you see P, in case they don't make P the subject, you just have to make P the subject, then multiply it times your Q. You get it? So this is what you are getting for the total revenue function. Now the question also says that we should write down the expressions for TR and MR. So it also says that we should find MR, which is our marginal revenue. So now let's find for the marginal revenue. Into brackets MR. And I told you that anytime they give the total revenue function and you want to find the marginal revenue function, just differentiate the total revenue function. Also, when they give the total cost function, you want to find the marginal cost function, just differentiate the total cost function. Then you get the marginal cost function, you get it. So now that you have the total revenue function, you want to get the marginal revenue, just differentiate it, that's all. So now, this is the total revenue function, which is 50Q minus 2Q squared. if I want to differentiate this to get the marginal revenue function, from what I said anytime you have a number and a variable attached to it and there's no exponent, you assume that the kill is not there. So to be 50, so you can just say the TR over the kill. Anytime you're differentiating something, just bring the D sign D, then whatever is at the left hand, so DTL, then over under D, then the variable that is here, the kill, you get it. So when you differentiate this, you're getting 50. 50k, when you differentiate 50k, you're getting 50. You assume that the variable is not there. Then minus, I told you that anytime you have an exponent and a base, you multiply the base times the exponent. So negative 2 times 2, you're getting negative 4. Kill 2 minus 1 is 1, so negative 4k exponent to 1 is the same as negative 4k. You get it? So this becomes our marginal revenue, 50 minus 4k. So you can just come and write the marginal revenue is equal to 50 minus 4k. So every time, if you're asked to find the marginal revenue, just differentiate the total revenue, then get the marginal revenue. Now let's move on to the B. The B says that calculates the level of output that maximizes total revenue. Now let's move on to the B. So the B says that calculates the level of output that maximizes total revenue. Now when you're given a question like this and you're asked to maximize, the first thing you have to do is that whatever they're asking you to maximize, you differentiate it once. Now when you differentiate it once, what you're getting is either the minimum point or the maximum point. Now after you found the minimum point or the maximum point, you have to differentiate it again to see whether it is minimum or maximum. So when you differentiate it for the first time and you, let's say, get maybe 10 or 20, it means that could be your minimum point or your maximum point. Now when you differentiate it for the second time and you get something less than 0, in other words, you get a negative, then it means whatever you got first was your maximum point. But when you differentiate it for the second time and you get something that is positive, it means whatever you got first is your minimum point. I know it sounds a bit confusing. When we solve an example, you get it. So let's go to the B. So the B says that we should calculate the level of output that maximizes total revenue. So now, anytime you're given a question, let me do it at this side. You see, let me clean this part. Yeah, so anytime you're given a question like this where they ask you to maximize total revenue, whatever they're asking you to maximize, you differentiate it for the first time. You get it? So now they're asking us to find a level of output that maximizes total revenue. And this is the total revenue function. 50k minus 2k squared. So the first thing we do is that we differentiate it for the first time. You get it? And we've already done it here, so we don't even need to stress ourselves. So when we differentiated it for the first time, so dtr over dq, we got 50 minus 4q. 50 minus 4q. So that's the first thing you do. Now the next thing you do is that after you've differentiated it, you equate it to 0. You get it? So we are getting 50 minus 4q. So we now equate it to 0. So 50 minus 4q is equal to 0. Then we make q the subject. So 50 is equal to, you can send 4q to the other side of the equation. So 50 is equal to 4q. Then now to make q the subject, we can divide both sides by what is multiplying q, which is 4. So we divide here by 4, divide here by 4. Then here will cancel here. So I'm getting q is equal to 50 over 4. That should be 12.5. So now, whatever you get when you do this is either the minimum or the maximum point. You get it? But if you want to know whether it's the minimum or the maximum point, you have to differentiate it for the second time. When you differentiate it for the second time, you put 12.5, whatever you've got here, in that equation. If you get a negative, it means it's the maximum point. But if you get a positive, it means this 12.5 is the minimum point. You get it? So now, if you also differentiate it for the second time and there's no variable in it, and you get a negative, then it means that that's the maximum point. So the whole point is that the first time you differentiate it, when you equate it to 0, whatever you are getting shows you either the minimum or the maximum point. Then the second one, when you get a negative, it shows you that it's the maximum point. When you get a positive, it shows you that it's the minimum point. All right. So having understood that, you're going to differentiate this for the second time. So whatever you differentiated first, which is the 50 minus 4q, you're going to differentiate it for the second time. When you differentiate it for the second time, you are getting something like, you can do it the CR square over the Q square. So 50 minus 4K, when you differentiate it for the second time, this 50 becomes 0 because I told you that anytime you differentiate a number, you are getting 0. So the 50 becomes 0. The negative 4K, when you differentiate negative 4K, I told you that when you differentiate a number and it's attached to a variable, you only take the number, so it becomes negative 4. The K will not be part of it. You get it? So now, when you differentiated it for the second time, you realize that you're getting a negative, which is negative 4. So this negative 4 tells you that the 12.5 you got is the maximum. You get it? The question asks for the maximum out, the level of output that maximizes total revenue. So therefore, the level of output that maximizes total revenue is 12.5. You get it? Assuming we differentiated for the second time and we got, let's say, 4, that's positive 4, or any positive number, it means this 12.5 would have been our minimum point. You get it? But once you differentiate and you get a negative, it means that's your maximum point or your maximum output. You get it? So now if you want to know the maximum revenue you can make, you can put the 12.5 into the total revenue function to know the highest revenue you are making. So here's the total revenue function, 50K minus 2K squared. So now you put the 12.5 in it. So you are getting 50 into bracket 12.5. So 50K, so 50 into bracket 12.5 minus 2 into bracket 12.5 square. So when you punch this on the calculator, so 50 into bracket 12.5 minus 2 into bracket 12.5 square. Yeah, so we are getting 312.5. So it means that's the maximum revenue we can make. But that one was not part of the question. The question just said you should calculate the level of output that maximizes total revenue. So the level of output that maximizes total revenue is 12.5. You get it? You can end there. I was just letting you know in case they ask you for the highest revenue, you just put the maximum output into the revenue function or the total revenue function. And that's how you go about it. You get it? So anytime they give you questions like this, they are just trying to test your knowledge on differentiation. You get it? So this is under applications of differentiation. Now let's take another question to see how we'll tackle it. Alright, so let's take another question. So the first one, we looked at marginal revenue. Now this one, I'm going to look at marginal cost. So the question says that if the average cost function of a good is AC is equal to 2K plus 6 plus 13 over K, find an expression for MC if the current output is 15. Estimate the effect on TC of a 2-unit decrease in K. Alright, so you've been given the average cost of the function to be, so we have AC is equal to 2K plus 6 plus 13 over K. So this is the average cost function you've been given. And they are saying that you should find an expression for MC if the current output is 50. Estimate the effects on total cost of a 2-unit decrease in K. So now they are saying we should find an expression for MC. So we first have to find for MC. But I told you that anytime you want to find for marginal cost, you have to differentiate the total cost function. So please don't forget this. If you want to find for the marginal cost, you have to differentiate the total cost function. Also, if you want to find for marginal revenue, you have to differentiate the total revenue function. So now that we know that if you want to find for marginal cost, you have to differentiate the total cost function, we first have to find for the total cost because it hasn't been given to us in the question. You get it? In the question, they've only given us average cost, but you can find for total cost because total cost is the same as average cost times quantity. So total cost is average cost times quantity. So please put this in your head. This one is just a formula that you have to choose. So total cost is average cost times quantity. You've already been given the average cost. So now you can just multiply the average cost times the quantity, which is your K. So now our total cost is our average cost, which in the question, they give us the average cost as 2K plus 6 plus 13 over K. Get it? So this is our average cost. Then times the quantity times K. You get it? So to find our total cost, we just expand this. So 2K times K is 2K squared. Then plus 6. 6 times K is 6 k. So plus 6 k. Then plus 13 over k times k. This k will cancel this k. So you are getting plus 13. You get it. So now our total cost function is 2k squared plus 6k plus 13. So now that we found the total cost function, we can go ahead to find the marginal cost. You get it. So now, what did the question say? Find an expression for marginal cost if the current output is 15. So let's find the expression for the marginal cost first. So like I said, when you want to find the marginal cost, you just differentiate the total cost function. Then you get the marginal cost function or the marginal cost. So now, if you want to differentiate the total cost function, we say the TC. So you bring D, then whatever is here, so the TC over the Q, you get it. So you just bring D, whatever is here, then whatever is after the equal sign, you bring it at the denominator. So dTC over dQ will be, so now we are differentiating this function. So you have 2q squared, and I said anytime there's an exponent, you multiply the exponent by the base. So you are getting 4q, right? This 2 is supposed to reduce by 1, so you're getting 4q exponent 1, but it's the same as 4q, so you can write it as 4q plus 6q. I said if you have a number and a variable attached to each other, whereas there's no exponent, you just assume that the variable is not there, so plus 6 plus 13. When you differentiate 13, you get 0 from what we said earlier. So now, when we differentiated the total cost function, you are getting 4q plus 6. So this 4q plus 6 is our marginal cost. So our marginal cost is 4q plus 6. Yes. So the question said that we should find an expression for marginal cost, which is what you just did. Then if the current output is 15, estimate the effect on total cost or TC of a 2-unit decrease in K. So if the current output is 15, the current output is the K, which is the quantity. So they are saying that if K is 15, estimate the effect on TC. You get it. So now we are going to put 15 into the marginal cost function. So output, this K is the same as the quantity or the output is the same thing. So they can also say the quantity is 15. So now they say that if the current output is 15, we just put 15 into this equation and see what you are getting. So 4 into brackets 15 plus 6. So 4 times 15 is 60. 60 plus 6 is 66. So we are getting 66. So what that means is that if the current output is 15, our marginal cost is now 66. You get it? Our marginal cost is now 66. But they are saying that we should estimate the effect on TC of a 2-unit decrease. A 2-unit decrease in K. You get it? So now what you are going to do is that if it's a 2-unit decrease, it becomes negative 2. Assuming they said a 2-unit increase, it would have been positive 2. But when they say a decrease, it's always negative. So you multiply the negative 2 times the 66. You get it? So now you are getting 66 times negative 2. And that should be 66 times negative 2. It's giving us negative 132. Get it? So our final answer is negative 132. So what that means is that when there is a 2-unit decrease, or when there's a decrease in output by 2, it's going to reduce our total cost by negative 132. That's what it means. So we are done with this question. So yes, so if you are given a question like this is how you go about it. So the first thing you have to put in your mind is that when you want to find the marginal cost, you first have to find the total cost if it has not been given. Then differentiate the total cost to get the marginal cost. You get it. Then whatever information they've given to you, just punch it in the marginal cost function. So if they say the output is 15, punch it in it, you get your answer, which is 66. If they say a 2-unit decrease, it means it's negative. So negative 2 times whatever you got. If they say maybe a 5-unit increase, it will be positive. So you multiply 5 times whatever you've got, you get it. So this is how you go about a question like this. So yes, you are done with this particular question. Now you can also use differentiation to find the maximum profit you can make in a business, you get it. So the next you are going to look at is what we call optimization of profit functions as well as production, you get it. So yes, if you're in a business and you want to know the highest amount of profit you can make, you can use differentiation to go about it. So let me clean the board. So now let's move on to optimization of profit functions. You get it. So this way, if you want to know the highest profit you can make in a business, this is what you use. You get it. So now it's the same procedure as what we were doing earlier. It's just the same application. So we are going to take a typical exams question to see how we go about it. Should a question come from it? So now the question says, Maximize the profit for a firm, given that its total revenue function is given by TR, which is total revenue, is equal to 4,000 kil minus 33 kil squared, and its total cost function is given by TC is equal to 2 kil cube minus 3 kil squared plus 400 kil plus 5,000. Assuming kil is greater than 0. All right, so you've been given the total revenue and the total cost function, and they're asking you to find the highest profit you can make. Now, let's write the information on the board. So, we've been given our total revenue to be 4,000 kil minus 33 kil squared. So, 4,000 kil minus 33 kil squared. Then we've also been given the total cost function to be 2 kil cube minus 3 kil squared plus 400 kil plus 5,000. So this is the information they've given to us, and we're asked to maximize the profit for the firm. Now, anytime they give you a question like this, the first thing you have to know is that you have to find the profit or the profit function. Now, from economics, you know that profit is total revenue minus total cost. So if you've been given the total revenue and the total cost, you can just subtract. So we can just say our profit. So you represent profit by pi in this topic. So profit is equal to total revenue minus total costs. So our profit is equal to, so our total revenue is 4,000. Let me put it in brackets. So 4,000 kil minus 33 kil squared. This is our total revenue minus our total cost. So minus into brackets 2 kil cube minus 3 kil squared plus 400 kil plus 5,000. So this is our profit function now. So you are going to simplify. So all what I just did is I substituted what we have here. So the profit is total revenue minus total cost. This 4,000 kil minus 33 kil squared is our total revenue. This TC is our total cost. So minus the total cost, which is 2 kil cube minus 3 kil squared plus 400 kil plus 5,000. So just subtract the total cost from the total revenue. You get it? Anytime the question is given to you, the first thing you have to do is subtract the total cost from it. So total revenue minus total cost. Total revenue minus total cost. So now you can just group like terms. So let's first expand the bracket. So now you are getting our profits to be 4,000 kil minus 33 kil squared minus the negative is affecting all here. So negative 2 kil cube. The negative 3 kil squared. So positive 3 kil squared. The negative 400 kil. The negative 5,000. Right. Now let's group like terms. So our profit is equal to, so now in grouping like terms, you can bring the one with the highest exponent first. You get it? So I'd advise you to do this. Anytime you are asked to find any function, just bring the one with the highest exponent first. So the one with the highest exponent is negative 2 kil cube. You get it? So negative 2 kil cube. So now we are done with this one. So let's underline it. You can also underline it so that you don't repeat any of the terms. You get it? So negative 2 kil cube. Then the one with the second highest exponent is 3 kil squared. So exponent 2. You also have another exponent 2 here. So we have negative 33 kil squared plus 3 kil squared. So you are getting negative 30 kil squared. So you can underline this and this to show that you are done with that one. Then we are left with 4,000 kil and negative 400 kil. So 4,000 kil minus 400 kil. So 4,000 kil minus 400 kil. You are getting plus 3,600 kil. You get it. Then lastly minus 5,000. Alright, so this is what you are getting. So anytime you're asked to find the profit function, I would advise you to arrange it like this. So the one with the highest exponent, which is 3, will come first. Then the 2, which is exponent 2, will come second. Then the one with the k will come third. Then the one without any variable at all become the last. You get it? So now this is our profit function. You get it? So the question says that we should maximize the profit for a firm, given that its total revenue function is given by this, and its total cost function is given by this. So now this is what you are supposed to maximize. You get it? So this is the profit, and you're asked to maximize the profit. So now the questions are all the same for this type of questions. So if you have the function and you're asked to maximize, the first thing you do is that you differentiate this and you create it to 0. Whatever you get, you could, most of the time you're going to get two values. Since you are having exponent 3 and exponent 2 and all that, you're going to get two values. Whatever you get shows you the minimum or the maximum profit. You get it? So usually one of the values is going to give you the minimum profit. The other value is going to give you the maximum profit. But if you want to really find which one is the minimum and which one is the maximum, you're going to differentiate again for the second time. Then you put the values in it one by one. The one that gives you a negative after you've differentiated for the second time is your maximum point. You get it? So all what I'm saying is that if you have something like this and you want to find the maximum point, you first differentiate this and equate it to 0. You get it? So you are getting the pi, so the pi, so the pi will come first over the q is equal to. So now we are just going to differentiate this. Now if you want to differentiate this, we have negative 2q cube. So negative 2q cube is, so 3 times negative 2 is negative 6q. Then we reduce the exponents by 1. So 3 minus 1 is 2. You get it? Then negative 30q squared. So negative 30 times 2 is negative 60. So negative 60q. Then reduce the exponents by 1. So negative 60q exponents 1 is the same as negative 60q. Plus 3600q. So for 3600q, we assume that the q is not there. So plus 3600. You get it. The negative 5000. Anytime you have only a number and you are differentiating it, it becomes 0. So this is what you are getting for the pi dq. Negative 6q squared minus 60q plus 3600. So now after we differentiated it, this is what you are getting. Negative 6q squared minus 60q plus 3600. So the next thing is that you equate this to 0 and find the q values. So you equate this to 0. So it's equal to 0. So from here, you can just punch it on the calculator and get it. So you go to mode, then 5, then 3. Then the exponent of q squared, which is negative 6. And it's equal to the exponent of q, which is negative 60. And it's equal to 3600. You get it? So this part, you don't need to, solve it step by step. Marks will not be awarded for doing this step by step. So when you get to this part, I'll just advise you to use your calculator. You just go to mode and 3 and punch in the coefficient. So you are getting x is equal to negative 30 and x is equal to 20. So here is q. So q is equal to negative 30 and q is equal to 20. But you know you can't produce a negative, you get it. Output cannot be negative. So always just take the positive one. When you get to this point and you're getting a negative one, just discard it. You always take the positive one, which is q is equal to 20. But this q is equal to 20 is the output that gives you either the maximum profit or the minimum profit. So if you want to know whether this q is equal to 20 is actually giving you the maximum profit, you differentiate it for the second time. Then put the q is equal to 20 into that function when you differentiate it for the second time. If you get a negative, then it means the q is equal to 20 gives you the maximum profit. However, if you get a positive, it means the q is equal to 20 gives you the minimum profit. You get it? So now we differentiate for the second time. So you are getting the pi square over the 2q, or the pi square over the q squared is the same thing. So now we are going to differentiate this for the second time. So negative 6q squared, if you want to differentiate, you are getting negative 6 times 2. So negative 12q. You get it. Then the exponent you reduce by 1. So negative 12q exponent 1 by the same as negative 12q. Then minus, so negative 60q, when you differentiate, you are getting negative 60. The q would vanish, you get it. So now when you differentiate for the second time, you get negative 12q minus 60. And when you get to this point, you take the q is equal to 20, which is a positive one. If they are both positive, you put all of them into it. The one that gives you the negative one is the one that gives you the maximum profit. You get it? So now, since you only have one positive, you put this into this equation. If you are getting a negative value, it means that the point that gives you the maximum profit. So now, negative 12k minus 60 is going to be negative 12 into brackets. So our k is 20 minus 60. So let's punch this on the calculator and see. So negative 12 into brackets 20 minus 60. So you're getting negative 300. Negative 300. You get it? So since you are getting a negative value, it means indeed the K is equal to 20 gives us the maximum profits. You get it? If when output is 20, that's when you are getting the maximum profits. You get it? But now, if we want to actually know the maximum profits we are getting, we put the quantity that gives us the maximum profit into the profit function, which is here. Then that's what gives us the highest profit. The K is equal to 20 is not the highest profit you are making. It's the quantity that gives us the highest profit. So if you want to know the highest profit you're actually getting in terms of money, we substitute it into the profit function because this is profit. So when you substitute it into this, whatever you get is the actual profit you are making or the highest profit you are making. So now let's do it and see what you are getting. So our pi is equal to negative 2 into brackets. So Q exponent Q. So our Q is now 20. Negative 2 into brackets 20 Q minus 30. Minus 30 into brackets 20 square. So anywhere we see Q, we are just putting 20 there. So minus 30 into bracket 20 squared plus 3,600 into brackets 20. Get to them minus 5,000. So let's punch this on the calculator. So whatever you get is what gives us the highest profit. So negative 2 into bracket 20 exponent 3 minus 30 into bracket 20 exponent 2 plus 3,600 into bracket 20 then minus 5,000. So you are getting 39,000. 39,000. So it means the highest profit the firm can make is 39,000. So this is what it means. So anytime they give you a question like this where you're asked to maximize the profit, this is how you go about it. First, find the profit and know that profit is equal to total revenue minus total cost. This is your total revenue, your total cost. So you subtract it, total revenue minus total cost. Whatever you get is your profit or your profit function. Then now you differentiate the profit function and equate it to 0. Whatever you get gives you the maximum output or the minimum output. But if you want to know if it's the maximum, which is what you are interested in, you substitute this 20 into the second derivative or when you differentiate for the second time. So when we differentiated for the second time, we got negative 12q minus 60. Then put the 20 into it. If you are getting the negative, it means that's the point that gives us the maximum profit. Then if you want to know the highest profit, we substitute the 20 into the profit function and we get the highest profit. You get it? So yeah, so you guys can try and solve more examples on it in case you find it a bit confusing, so you'll be able to get very familiar with it. So now the last thing we're going to look at is how to optimize the production function. Alright, so the last thing we're going to look at for today is how to optimize production function. So it's also the same as this one. We're just going to go through the same procedures, then we call it a day. So now let's take a question on how to optimize production function. So it says a firm's short-run production function is given by Q is equal to 6L squared minus 0.2L cubed, where L denotes the number of workers. A. Find the size of the workforce that maximizes output. B. Find the size of the workforce that maximizes the average product of labor. Calculate MPL and APL at this value of L. What do you observe? So MPL is the same as the marginal product of labor, and APL is also the same as the average product of labor. So now we are given a question where you want to find the workforce that maximizes output. It's the same maximize, so you go through the same process. So you've been given the short-run production function by the production function is kill is equal to 6L squared minus 0.2 LQ. You get it? So this is the short run production function. And the A says that we should find the size of the workforce that maximizes output. All right. So when you ask for the size of the workforce that maximizes output, in the short run production, always the output depends on the labor, only on the labor. That's why you can use differentiation to solve a question like this. So anytime they give you a question like this, where you see short run production, then you solve it like this. You get it? So now, if you have to find the size of the workforce that maximizes output, the same thing we've been doing. We first differentiate this. So we differentiate for the first time. So dk over dl. So now if you are differentiating this, we have 6L squared. So 2 will multiply the 6. You are getting 12L. The 2 reduced by 1, but 12L exponent 1 is the same as 12L. So yes, minus 0.2 times 3. So 0.2 LQ. So 3 will multiply the 0.2. You are getting 0.6, right? Then L. Then the exponent 3 will reduce by 1. Exponent 2. You get it? So now this is the first thing we do. And just like we've been doing previously, you are going to equate this to 0. You get it? So we are getting 12L minus 0.6 L squared is equal to 0. So if you want to rearrange it, you are getting negative 0.6 L squared plus 12L is equal to 0. So we bring the one with the highest exponent first. So negative 0.6 L squared plus 12L is equal to 0. Then here you can just point to the calculator. So this part you don't need to do it step by step because marks will not be awarded for it. So we go to more than 5. Yes, so more than 5, then 3. Then the coefficient for L squared is 0.6. Get it? And the coefficient for L is 12. Then here is 0, so 0 is equal to... So we are getting 0 and 20. So L is equal to 0, L is equal to 20. So you always take the positive one because obviously labor cannot be 0. You get it? It's not really likely. So L is equal to 20. So now this L is equal to 20 means that the size of the workforce that either maximizes output or minimizes output is 20. You get it? So now you are only interested in the one that maximizes output, not the one that minimizes. So if you want to be really sure that this 20 actually maximizes output, we differentiate for the second time, just like what we've been doing. Then if we get a negative, then it means this 20 actually maximizes output. So when you differentiate for the second time, we are getting the 2k over, or the k square over the l square is equal to. So when you differentiated for the first time, this is what we got. Negative 0.6 L squared plus 12L is equal to 0. So now we are differentiating for the second time. So you are getting, so negative 0.6 times 2, which will be 1.2, right? Negative 1.2. Sorry, so negative 1.2 L, right? Then this 2 will reduce by 1, so negative 1.2 L plus 12. So now if we want to be sure that this 20 actually maximizes output, because this 20 means that it either minimizes output or maximizes output. If we want to know that this 20 actually maximizes output, we put the 20 into this one, which is the second derivative, or when we differentiate for the second time. If what we get is negative, just like we were doing previously, then it means that this 20 actually maximizes output. So now we are having negative 1.2 L. So our L is now 20. Since we get 20 plus 12. So if we calculate and whatever we get is negative, then it means it maximizes output. So negative 1.2 into bracket 20 plus 12. So we are getting negative 12. So since we got a negative 12, it means this 20 actually maximizes output. So the question said I should find the size of the workforce that maximizes output. So the size of the workforce that maximizes output is 20. You get it? If we want to know the highest production we can make, we just punch the 20 into the short run production function. So to be 6 into bracket 20 squared minus 0.2 into bracket 20 cubed. And whatever you get is the highest production you are making. You get it? But since the question didn't ask us to look for that, There's no need to look for it. You get it. So now, yeah, so for the A, the size that maximizes output is the 20. Now let's move on to B. So B says that you should find the size of the workforce that maximizes the average product of labor. Calculate MPL, which is the marginal product of labor, and the average product of labor. At this value of L, what do you observe? All right, so let's clean the board and solve the B. All right, so let me read the B again. So the B says you should find the size of the workforce that maximizes the average product of labor. Calculate for the marginal product of labor and average product of labor at this value of L. What do you observe? So now we are first finding for the average product of labor, right? Now the formula for the average product of labor is equal to the quantity over labor. So what this means is that what each and every labor is bringing, you get, so the average product they are bringing, you get it. So quantity over labor. And the quantity has already been given to us in the question. So now the quantity, in the question they said KO is equal to 6L squared minus 0.2 LQ. So the quantity is, which is already in the question, 6L squared minus 0.2 L cubed. This is our quantity, which is our numerator. Then over labor, you get it. So this is our average product of labor. So our quantity is the 6L squared minus 0.2 L cubed. This is what is given to us in the question, then over the labor. So now we can just use L to cancel out. So we are getting, so L will go into itself once and cancel one of this 6L squared. So you are getting only 6L, right? Then L will also go into itself 1 and cancel one of this L cubed. So you are getting minus 0.2 L squared. I hope no one is confused. This is the Q over L is 6L squared minus 0.2 L cubed over L. So now we are using L to divide both of them. If we have 6L squared, so the first one is 6L squared over L. So L will cancel one of this L squared. The L is 2. Then to be left with 1L. Then L will also cancel one of this. This one is 3. Then to be left with 2. So minus 0.2 L squared. I hope you get it. So now this 6L minus 0.2 L squared is our average product of labor. This is equal to our average product of labor. So now the question says that we should find a workforce that maximizes the average product of labor. So now this is the average product of labor. If you want to find a workforce that maximizes it, the same thing, we differentiate. So now if you want to differentiate the average product of labor, so you differentiate the average product of labor to the APL over DL. We are getting, so we want to differentiate this. So 6L, if you differentiate 6L, we are getting 6. Because I said when a number and a variable is attached, you just take only the number. So 6 minus 0.2 L squared. If you want to differentiate this, so 0.2 times 2, we are getting negative 0.4 L, right? Because this 2 will reduce by 1. All right, so when you differentiate for the first time, you're getting 6 minus 0.4 L. So you can now equate this to 0. So you're getting, so when you equate this to 0, you can get 6 is equal to 0.4 L, right? Then divide both sides by 0.4. Divide both sides by 0.4. So here will cancel here. So our L will be equal to 6 over 0.4. So 6 over 0.4. You are getting 15. You get it. So it means the size of the workforce that either maximizes or minimizes the average product of labor is 15. You get it. But we're only interested in the one that maximizes it. So we differentiate for the second time. When we put 15 into it and we get a negative, it means that's the workforce that maximizes it. You get it. So now when we differentiate this for the second time, we are getting, so the APL squared over the L squared. When you differentiate this for the second time, you are getting, so when you differentiate 6, you are getting 0. So the negative 0.4 L, you are getting negative 0.4. So when you differentiate for the second time, you're already getting negative 0.4. So you don't even need to substitute 15 to it. So once you are getting a negative, it means that truly this 15 is the size of the workforce that maximizes the average product of labor. You get it. So you can just state that therefore the size of the workforce that maximizes the average product of labor is 15. You get it. The question moves on to say that we should calculate MPL and APL at this value of L. What do you observe? So now we should calculate for the average product of labor at 15. So we just put 15 into the average product of labor function. You get it. So this is the average product of labor function. So we are getting, so I can just do it somewhere here. So we are getting 6 into brackets L, which is 15, minus 0.2 into brackets 15 squared. So when we punch this on the calculator, we get into 6 into brackets 15 minus 0.2 into brackets 15 squared. So we are getting 45. You get it. So our average product of labor is 45. You get it. So now the second one says that, yeah, so calculate MPL and APL at this value. So this is the APL. So now let's calculate for the MPL. Now, MPL is marginal product of labor. And if you want to find the marginal product of labor, you just differentiate the total product function. You get it. And the total product function is what is given in the question. They said a firm's short run production function is given by K is equal to 6L squared minus 0.2 L cubed. So, okay, let's do it somewhere here. Get it. So in the question, they gave us K is equal to 6L squared minus 0.2 L cubed. This is the total product. And from the beginning, I said that once they give the total or something, you want to find the marginal, you just differentiate this. You get it. So if you want to find the marginal products, is the Q over the L. So that will give us, so 6 times 2 is 12L. So 6 to 12, then times the L. Then minus 0.2 times 3 is 0.6 L squared. This still reduced by 1. We even did this earlier on, so I'm sure you guys remember it. So now that we've got, so this the Q, the L, or when you differentiate the total product function, whatever we got, which is the Q, the L, is a marginal product. You get it. So this is the marginal product function. So now we are asked to find the marginal product of labor when the L is 15. You get it. So you just substitute 15 into this. So you are getting 12 into brackets 15 minus 0.6 into brackets 15 squared. So when we punch this on the calculator, let's see what you are getting. So 12 into brackets 15 minus 0.6 into brackets 15 squared. So you are getting 45. So it means our marginal product is 45. And our average product was also 45 as well. So it says, what do you observe? So you say that you observe that the marginal product and the average product are the same. You get it. So yeah, so we are done with this. So if you are given a question like this, just put it to your head. It's all about differentiation. So for the A, find the size of the workforce that maximizes output. You first differentiate for the first time, then you equate it to 0. Whatever you get, the positive one is the point that either minimizes or maximizes output. If you want to know whether it really maximizes output, you differentiate for the second time. If you are getting a negative, then it means that it maximizes output, you get it. Then you do same for the average product and the marginal product. It's the same thing. For marginal product, if you want to find the marginal product, you just take the total product function, differentiate it, you get a marginal product function. Then you know that for average product, it's equal to the Q over L, or the quantity over labor. So please try and keep this formulas in your head, you get it. Alright, so that's the end of today's video on differentiation. The next video, we are going to look at partial derivatives. We are going to look at two variables when you want to differentiate in respect to two variables. So this one, we're just differentiating with respect to just one variable. This one like this, you had only L there. But what happens if there are, two or more variables? That's what you are going to look at in the next video. Thank you so much for watching this video. If you like this video, don't forget to like, subscribe, comment, and share. And I'll see you in the next video.